Hello everyone. So the objective of this lab assignment is how to create threads and how to implement its different functions, which includes p thread create, p thread join, and etc. etc. So we'll be looking into the thread creation and its different functions. So firstly, the question comes that what exactly is a thread, or what is the concept of threading in operating system. So basically, within a program, a thread is basically a separate execution path. Okay, it is nothing but a lightweight process. So thread is basically a lightweight process that the operating system can schedule, and they can run concurrently with other threads. So the important idea of thread and using multiple threads is to achieve parallelism in operating system. So in order to have parallel execution, we use thread. Now, for example, whenever you browse something on internet, so you see separate tabs there. One tab, you open one tab, you perform some functionality in that tab, then you go ahead and open another tab and you perform some other functionality with that tab. So the multiple tabs that you open on the browser implements the concept of multi-threading. Similarly, let's say you use MS Word, the Microsoft Word. So MS Word also uses the concept of multi-threading. So how it can schedule different threads for different purposes. Like it can schedule one thread for maybe language checker as a language checker. Okay, one thread for let's say formatting the text. Okay, so and another one test for maybe processing the input, anything. So you can have different threads to perform all the same functions. So what is the primary difference between a process and a thread? Why exactly are we using the thread? There are many reasons. So the primary difference between them is the concept of shared memory space. That means with the help of threads, you can share the memory, and this saves a lot of memory. With process, what you have to do, you have to create a separate memory for a process. But for a thread, you can share the memory. And similarly, you can share many other things with threads, like you can have the same code section, you can have the same data section, and you can also share some operating system resources. So all these things you can share with the concept of thread, and that's why it is a lightweight process, right? Because ultimately it is also doing the same functionality what a process could do. Like the example which I explained you in the previous lab, that let's suppose you have an option to put your pen from one place to another using your hand. So if I talk about the process, what the process would do, the process would use a different hand or would create a separate hand to perform this task. So obviously you see, creating a separate hand would require lots of resources, whereas if I talk about a thread, okay, and let's say if I want to perform the same operation with the help of a thread, so what thread will do, thread will create just a different fingers for that. Okay, so maybe a different finger for you is created, which is performing again the same operation that you wish to do. So again, you can see, creating a different finger, obviously there the resources are getting shared, whereas when you create a separate process, there the resources are not shared and everything is different. But obviously there is some whenever you create a separate thread, they do have something that is not in common, which includes the counters, the registers, the register set, and the stack space. So obviously the threads, when we talk about thread have some different sections which they don't share, which include the program counter. So each thread has their own program counter, the PCs which we refer, the different register step set and the different stack space. So this is different for every thread, so that we can keep track of the progress of each thread and what exactly it is currently doing, and what where it is in which section of code it is currently present. So the advantage of thread is that they help in faster response you get, because again not much time is created, not much time is getting wasted in creating a different memory space, creating a different code section or operating system resources. Everything is shared that way, so the faster response you get. Then you also get faster context switching. So context switching, which we just saw, so context switching is also quite fast when we talk about the threads or using different threads. This is also one advantage. Now again, next advantage is resource sharing. So the resources are also shared. You are able to implement the concept of multi-processor system quite efficiently. So multi-processor system or parallelism is very easily achieved in case of threads. And increase, so obviously if all these things will be there, so throughput will obviously be increased. So throughput of the system is increased that way. So all these are the advantages of using threads and its different functions. So as we talk about different functions of thread, now the different functions that we use whenever we talk about thread are as follows. So first function is thread create, the very basic function which we use in for creating a thread is thread create. So obviously it is used to create a new thread, and the function is declared as follow. Int is its return type, pthread create. Okay, in the parameters we passed pthread underscore t thread pointer const pthread, then void star start routine. So these are the four parameters when we talk about thread. So what are these four parameters? The first parameter, it is a pointer. It is a pointer to what? To an unsigned integer value that returns the thread ID of the thread created. So the first pointer, it returns or it points to the thread ID of the newly created thread. So this function is obviously used to create a new thread, and inside that, the first parameter, it is the pointer to the thread ID of the newly created thread. Now second parameter, which is this attr pointer. So again this is also a pointer, but this is a pointer to the structure that is used to define the thread attributes like detached state, scheduling policy, etc. So what this next attribute does, this attributes, it is again a pointer that is used to define the thread attributes like detach state, the scheduling policy, and many other things. So it tells whether, so we'll also see the different states of the thread. So sometimes thread is in the detached stage, means thread is detached. So there this pointer would reflect that which state it is. So it points to different attributes of the thread, but the default value of this is null. So whenever you create a thread, by default it will be set to null, and this is the default thread attribute for the newly created thread. So by default you will set it to null. Third is the start routine. So again, the start routine is also a pointer that we can already see, and this is a pointer to the function that will be executed in the newly created thread. So basically this function start routine, it points to the function that will be executed by the newly created thread, which means whenever we create a thread, so we create it for a purpose and we define that purpose in a function. So the name of that function will be passed to the start routine parameter, so that thread could easily understand that I need to execute this particular function. Next, the last is the void star argument. What it does, it is nothing, it is just a pointer that will be passed as an argument to the start routine function. Okay, so this is nothing, this is just a pointer that is passed to the start routine function. So when we see the example of this pthread create process, then you can exactly differentiate what exactly these two parameters mean. So first is the first parameter, it returns the thread id of the thread. Second parameter tells you that whether the thread has any attribute associated to it or not, whether it is in the detached state or the scheduling policy of that thread. If not, then it is set to null. So initially it is majority of the time set to null only. Third is the start routine, which again says is a pointer to the function that will be executed as soon as the thread is created. And void star argument, it is a pointer that will be passed as an argument to this start routine function. And if successful, this function, what it returns, so this function returns 0 if it is successful, okay, on success. Otherwise it return and also the thread object is updated with the thread id of the newly created process, so it returns 0. And we also get the thread id of the newly created thread from this, because obviously the first pointer, it returns the thread id of the thread. So on success it gives you 0 as well as it gives the thread id. Now the second, let's look at the second function. So the second function here is the pthread exit. So what the pthread exit function do? So again, the pthread exit function, this function is basically used to terminate the thread. So this function, as the name itself implies, is used to terminate the thread. And the structure of this particular function is like this. You use void pthread exit function, and in the parameter you pass the pointer ret val. So this is what, this is a pointer to an integer that does what, that stores the return status of the thread that is terminated. So pthread exit is used to terminate a thread, and it is used to and in the parameter it is, it points to an integer that stores the return status of the terminated thread. Return, why we need the return status? Because we want to see whether the thread terminated properly or not. Whenever the thread is terminated, we have to see whether the all the resources that were initially associated with the thread got terminated properly or not. So to check that, we use the pthread, the pointer ret value parameter, which gives the status of the terminated thread. Now third important function here is the pthread join. So this is used to wait for the termination of a thread. And how is it written? It is written as int pthread join pthread th. So the th here is the identifier of the thread that need to be joined, and this is the return status of the thread. Now what exactly happens is, suppose we have the main function that is currently executing, okay, and inside the main function you create one thread. Now in that case, two thread will start running. One is the main thread that is running, and second is the newly created thread that you have just created. So what will happen? It can happen that the newly created thread finishes later, and the main thread, it finishes first. First the main thread is finished, and then the newly created thread is finished. But we don't want that, because ideally the newly created thread is inside the main thread, right? So we, what we want is, we want that the newly created thread should terminate first, and then the main thread should finish. So if the main thread terminates before the new thread will continue to execute until it has completed its execution. So to synchronize the termination of the new thread with the main thread, what we want, we can join that, these two thread with the help of pthread join function. So it helps to synchronize the thread. Now as soon as we join the newly created thread with this thread, what will happen? This will cause the main thread to block until the newly created thread completes its execution. And once the new thread, it has terminated, then its exit status is returned through the return parameter. So this parameter, it is used to return the exit status of the newly created thread, that so that main process could understand that okay, the newly created process has terminated now. So the main thread could get this notification. So this pthread join function is used to synchronize two threads basically. The fourth function is pthread self. This is used to get the thread ID of the current thread, and its syntax is as follow: pthread underscore t pthread underscore here. So this is the syntax of this particular function. So what it does, suppose as I already explained that we have two threads, we have one the main thread and then we have some newly created thread, and we want to see currently which thread is executing. We don't know internally the operating system is executing which thread, so that we can find with the help of pthread underscore self function, because it will give you the thread id of the current thread that is executing. So this is pretty much simple. It is used to give you the thread id of the current thread. Next, fifth function is pthread equal. So what this function does, it compares whether the two threads are the same or not. If they are equal, they are same, then the function returns a non-zero value, otherwise it returns 0. Okay, and it is defined as follow. So this is how this function is defined. So basically you can see in the parameter we have passed two threads T1 and T2. Okay, so T1 and T2, what it does, pthread equal compares T1 and T2, which are the two threads here, and see whether the two threads are same or not. If they are same, then it return a non-zero value, otherwise it returns a 0 value if they are not same. Next function is your pthread cancel. So it is again used to send a cancellation request to a thread. So if you want to cancel any thread, you need to use this function. So in this case, the thread will get the cancellation request, but it doesn't mean that the thread will be cancelled. It will see that in which exact state the thread is there, whether I can cancel it or not. So it is basically used to send a notification or a request to the thread to cancel, and this is obviously the uh, format, the function how you can cancel a particular thread. So again, this is pretty much self-explanatory, and the final function is pthread detach. So it is used to detach a thread that was earlier joined. Okay, and a detached thread does not require one very important thing. We looked at the pthread join function. So suppose the main thread and the newly created thread are joined, so that their synchronization is so that we can achieve the synchronization between the threads. But let's say I now want to detach them, so I can use this function pthread detach in order to detach them. But again, once they are detached, that doesn't mean that the they need some other thread to join. No, they can execute on their own also. So a detached thread does not require a new thread to join on terminating, and the resources of the thread are automatically released after terminating if the thread is detached. Right, so if it is detached, so obviously after terminating the resources will automatically get released, and the again function is declared as follows. We have the pthread detach. So this again pretty much self-explanatory. It accepts a mandatory parameter thread, which is the thread ID of the thread that must be detached. So again, pretty much self-explanatory this is. So basically these functions which we saw here, they are different functions that helps to achieve parallel, that helps to achieve multi-threading and parallel synchronization of the different threads. So first we looked at pthread create, which is used to create a thread, then pthread exit, which is used to terminate a thread, then we saw pthread join, which is used to again join different threads which are running so that they are synchronized properly and run properly. Then we have pthread create. So pthread create is used to again, with the help of this function pthread self, it is you can get the thread id of the current thread. Pthread equal is used to compare two threads, whether the two threads they are same or not. If they are same, so a non-zero value is returned. If not, then a zero value is returned. Pthread cancel is used to send a cancellation request to the thread, and detach is again used to detach a thread. Now the question comes, what is the difference between pthread exit, join and detach function? We saw all the three functions here. So pthread exit that we saw, it is used to terminate the execution of the cell of the thread and return a result early. Okay, so as soon as I call the exit pthread exit function, at that particular time only the thread will be terminated, no matter in whatever state it is. Whereas what pthread detach, again what pthread join does, or let's say what pthread cancel does, there is also one more function, pthread cancel. Pthread cancel will send a cancellation request to the thread, but that doesn't mean that the thread will have to cancel at that particular time. It see that it is used to check what is the current status of that thread, whether it could terminate now or not, or let's say it is performing some very important function and it cannot terminate. So in that case it is not terminated. So but pthread exit, it has to terminate at that particular time. And pthread join, we already saw that pthread join is used is called from another thread to wait for the thread to terminate and obtain its return value. Detach is can be called from any thread. It can be called either from the thread itself, the main thread that we saw, or maybe the another thread, the newly created thread, and it indicates that you don't want both the threads to run parallelly. And again, you don't, as soon as the thread exit, so you don't want that, it is not mandatory that the detached thread wants some new thread to be joined again. So these are some of the important functions when we talk about threads. Now the objective is this. So the objective is uh, to create thread using different functions. So problem first says, suppose you are developing a multi-thread program that requires the support of two threads to print the even and odd numbers alternatively. Let's say starting with the odd numbers, or maybe let's say starting with the even numbers. Okay, let me correct it. Starting with the even numbers, you decide to implement the odd number printing task in a separate thread using pthread library. Write a C program that creates a thread to print odd numbers from 1 to 100, while the main thread prints even number from 2 to 100 and ensures the threads execute in desired alternating order. So again, the objective is just to print the even and odd numbers alternatively. It could happen that first the odd numbers are printed and then the even number are printed. That could also happen. So here I first printed the even number and then the odd number. So how this is achieved? First I will include the pthread library, okay, which contains the definitions of all the functions that are related to threads. Then I made this function, print odd number function, okay, which directly prints the odd number from 1 to 10. Then there is another function, the main function. This is the second function here. So inside main function, you see I created the thread object. Then I called the first function, which is the pthread create. So if you could remember, the pthread create takes four values. Okay, first value it takes is the pointer to the thread, so the thread id. So you can see here the first parameter that the thread was taking is what, the pointer to the unsigned integer value, that is the thread id. So first is that. Second is null, because it defines the routine, the attributes. So attributes here are null, default values there. Third is the function to which the thread will point once it created and execute. So here the thread will point to this particular function, print odd number. It will point here at at this particular place. So again it points here, and then fourth argument is again null, because it is again the pointer that will be passed as an argument to the start routine function, and we have set it to the null, the default value. So now I start printing. I write printing even numbers, and I print the even number. So basically what happens, so initially this is being executed by the main thread. Okay, so I got the output printing even numbers, and even numbers are printed first. Then I write printf, and I again used now the pthread join function. So what join function does, it joins the newly created thread with the current thread, that is the main thread. So this is the newly created thread that we just created. So the newly created thread, the value is passed here, and the null value, the default value, is passed here. Then as soon as the join function is called, so the newly created process starts executing, and it executes this main function. So next the odd numbers will be printed from 1 to 10. So that's it, and then after that the program gets terminated. So that's how you get the value first, the even numbers or odd numbers, whatever numbers that you have written inside the main function, that would be executed, and then the second set of numbers would be executed. Now the second question says, suppose you are developing a video game that requires a lot of processing power, and you want to optimize the performance of the game by using multi-threading. So what you want to use, you can use functions like thread create, equal, join to create and manage multiple threads that can handle different tasks in your game, like rendering graphics, playing sounds, etc. So you need to write a C program that implements this situation. Now how this is being done, and the second part is, suppose you are encountering an issue where some threads are not terminating property and are causing a delay. How can you modify the C above program to resolve this issue and ensure the termination of all the threads properly? So what again we have done, included the main header file that would be implementing the multi-threading concept. I've declared one function which is void pointer function, and again one function here, that is the void function. Okay, second function here, and the main function here. So what we do, first give a call to this main function here, this function fun, which is being called from the main function. Inside that I am using different, so the objective of the second question is to implement the different functions that we just saw with the thread, with in the ppt with respect to the threading. So first a thread identifier is getting created. First I use the pthread create function to create a thread. So again PID is uh, written here as an argument. The line is printed, this line may be printed before the thread terminates. So this line is printed first, then again initially all this is comment, because if I write pthread cancel, so obviously it will be sending the cancellation request to this thread, and it will be cancelled and nothing would be executed. Okay, so initially this is comment. You can uncomment it and see what exactly happens with this function. Then it compares two threads. So second function here is the comparison one, pthread equal. So pthread equal sees the newly created thread and the currently executing thread, so that the idea of the currently executed thread you get it with this third pthread self function. Okay, so it, if they are equal, threads are equal, that is printed, otherwise threads are not equal, that is printed. So again, that could have been printed if you cancel the, if you have written this state, if this statement is uncommented, then this would cancel the newly created thread. In that case, the ptid and thread could be same, and then threads are equal could be printed. Then the fourth function that is getting created is the pthread join. So what this is doing, this is joining the newly created process id with the main function. And as soon as I write pthread join, so this function is getting executed. Why this function is executed? Because the ptid, this thread points to the function definition there here. So this, it is pointing at this function only. So that's why this function is getting uh, run. So inside this I called another function which is pthread detach. So fifth is the detach function. Now I have, as soon as this function is getting executed, I detach the current thread from the calling thread. Okay, and inside this pthread self is giving you the thread id of the currently executing thread, which is the newly created thread, and then you get inside the thread that is being printed. And next is pthread exit, which is again terminating the current thread. And after terminating, it comes here and this line is getting printed. And now the main thread that is also terminated. So you see different, some 5 6 7 functions of the threads that are being used in this function. Okay, you have created the thread, then you have compared it with the newly created thread, you have joined them, then you have detached them, then you have also compared them, then you have exit them. Okay, so that's how you can play around with the different functions that are associated with the threads and see how exactly they are working. So this is the idea of the lab 8, which requires you uh, to implement all the different functions that are related to threading. So okay then, thank